Okay, so basic trig identities. Like I said, you already know a couple. This is probably going to be one of the ones you use the most right there. Okay, that's going to be very useful. And then what's cotangent? Yeah, cosine over sine. Do you want to write it down? Okay, because I mean, you know those are reciprocals, so we can use that knowledge to our advantage. Okay, let me find where I'm at.
Wait, what's the one where you put the and in it?
That would be probably perpendicular slopes, yeah.
Oh.
Right? Yep. That would be okay. Okay, so just with these basic examples you already know, these are what we call of course trig identities. Basically what you're looking at it is two items that are equal to each other in equation. Okay. So you know what, you've been working with identities your whole life and equations, you just haven't known it. Okay. The thing about identities that's different, the Pythagorean theorem, right? You know that, but it has a condition. It has to be a right triangle to work, correct? Okay. But identities work. Okay, they work all the time. So if it's an identity, you know it's going to work. All right, so we can use it all the time. One thing that this is going to show you is what are called counterexamples. So can you show that it doesn't work? Can you show that it's not an identity? So something that might come up is something like this. And in your book, it would actually include in there by a counterexample. Okay. That's what I was telling you about earlier, where they're not equal to each other. Okay. So the question is, can I find a value of x to plug in here where those two are not equal? Okay. So if I write that in English, x where okay, so that's another way to write it. A little bit more English friendly, right? So, any ideas? This is where you just have to come up with one. So we're thinking in radians. Are there measures in radians? Okay, generally, pi over 4 is a good one to start with because it's easy, right? Pi over 4, you know, is root 2 over 2, root 2 over 2 for sine and cosine. So I'm going to try. Okay. You can use pi over 3, pi over 6, you can use 0, pi over 2, it's up to you. Generally, this is a good one to try. Okay, so sine pi over 4, cosine pi over 4. Does that equal tangent pi over 4? Hallelujah, we get to practice our unit circles. Okay. Sine pi over 4, anybody? Yeah, it is. That's what pi over 4 is, but what's the sine at pi over 4? There you go. Okay. And we remember that that always matches with cosine at pi over 4, right? Okay. Does that equal, what's tangent? 1. Yes. Remember, it's sine over cosine, so it'd be root 2 over 2 over root 2 over 2, which is 1. Is that true? Okay. Multiply, we get 2, right? Okay, let's go 5th grade here on us. What's 2 times 2? 4. Does that equal 1? Come on. Okay, so we've just shown by counterexample that that's not an identity. Okay. So basically you're showing it doesn't work at some point, so it's not an identity. So if you want to get formal, have you ever seen that before? On Ice Cube? Oh, the rapper? Yeah. Okay. Sorry. He was like really popular when I was your age. I haven't heard that name in ages. So if you want to get formal, you can write, therefore, sine x cosine x equals tan x is not an identity. Okay. It might work somewhere. In fact, I would almost bet that it does, but it does not work all the time. We've found one spot, so we know it's not an identity. Okay. Okay. Good. The hardest part's coming up with the one that doesn't work. You just basically pull them out of thin air and try them. Okay. And you're good to go if you find it. All right. No, wrong. It's amazing how much you forget over break. Forget how to use my computer. We've learned the 6 trig functions. There are identities that go with each one. So if I was to ask you what cosecant was, what do you remember that as? 1 over sine, right? That is an identity. Okay. You can also do secant, which is 1 over cosine, and cotangent. Usually, okay, I want to advise you to avoid this one as much as you can. It's 1 over tan. And encourage you to use those two because they're more simple. Okay, so try to avoid that one if you can. Now, if it helps you, great. And I'm going to show you how that might help you at some point. But if it helps you, use it. But if not, try the sine cosine thing. You can also write sine as 1 over cosecant. Okay, that's probably a new one on you, but it's just a result of the relationship there. Okay. Cosine, of course, can be written as 1 over secant. And then tan is 1 over cotangent. Okay. All these should be on your sheet that you have printed out. So you just have an automatic reference there. Okay. We have 3 more identities for today, and they're the basic ones, the one you're going to use the most. Okay. These are called the Pythagorean identities. What do you think they have? It's the squareds, just like the Pythagorean theorem. We just apply it to trig. Okay. This is, you can get all of these from one. Okay, this is the big one. Of course, you could add a squared on the one, but it doesn't do anything, and it looks like the Pythagorean theorem. That's exactly what it comes from. The unit circle and the Pythagorean theorem, and we get this result. Okay. So this one, you're going to use it a lot. It makes things really simple. You can take sine squared plus cosine squared, and it drops away, and you can put 1 in that spot. Okay. There are two others that we can derive from this. What is cosine squared equal to? If I subtract this over, 1 minus sine squared. And then what's sine squared? 1 minus cosine, right? Okay, those are subsets of this. You don't have to know them, memorize them. You can build them from it, but just know that you're going to use them. Yeah.
What kind of like problems those
We're going to get into that a little more tomorrow.
Okay.
These are just like purely informational today, basically. I'll show you a couple problems today that'll help with, but the big part of this chapter is solving trig equations. And that's where these are really going to pay dividends. Okay. We also have two others involving tangent and cotangent. Okay. And I think it's cotangent and cosecant right there. Okay, so those are your big basic identities. There's what, 1, 2, 6, 8, 9, 10, 11, 13 if you count those two. Okay. It's like drinking from a fire hose, right? Just found the marble in the oatmeal. Okay, so first way to use these is just finding trig values. Okay, so if I give you something like secant theta is 3/2, find cosine theta. So in the past, you've built a triangle, used the Pythagorean theorem. Right, so this is what we did in the past. Secant is hypotenuse over adjacent, right? Cosine is adjacent over hypotenuse. So well, that one's easy. That's what you just flip them, right? Okay, so we would know that cosine is 2/3. Right? That's the old non-identity way. Honestly, it's probably easier in this case. Okay. The identity way to do this, you know that cosine is 1/secant. Right? We had that right there. Okay, so you can use the identity to solve it as well. So 1/3/2 copy dot flip. You get the same answer, obviously. Okay, and I'm not going to concern myself with which method you use. I don't care. Okay, but it gives you another option. If you're a geometer like me, this is probably your best bet. If you're more of a trig algebra person, this is probably your better bet. Okay, whatever. Okay. Okay. All right, let's try one where we don't have to use an identity, but it makes it a lot easier. Cosecant's 4/3, find tangent. Okay. Okay. Do we have an identity relating the two? Yes? No? Yes? Is that right? Cosecant and tangent? No, I have secant and tangent. But I can find cotangent using cosecant and then flip it, right? Does that work? Okay, so this is an option. So I'm going to use, which one was that? All right. So you plug this in for cosecant and do the math. Okay. Cosecant is 4/3, and it has to be squared. Okay. Right. That squared just means the whole thing is squared. You can also write it like that if you need to. Okay. Some people see that a lot easier. All right, what's 4/3 squared? 16/9. And subtract 1? Yeah. Remember, 1 is 9/9, so we like to leave these in fraction form. And then what? Yep, you got it. Root. Oh, let's make that a whole side. Okay. So cotangent is positive or negative. The square root is 7/3. Right? Good. Now what's tangent? Yeah, that's awesome. Roots in the denominators. Got to simplify. There you go. Okay. That's the long road to getting to here. You can, like I said, you can still use a triangle if you want. But this is a good way for us to introduce to you how to use identities. Okay. You're going to get to a spot in the next few days where we have to use them, and being able to use them in more simple manners is proves dividends. So, any questions on that one? From here to here? Yeah, I did. Remember, cotangent and tangent are reciprocals. So I flipped it. Yep. So this would be it was on the first slide I did. Yeah. Or no, second. So I think we're good for today. Guide. Yep. Okay. Hey, you have 2 days to do the homework. Okay. I'm going to write down. If you want to start tonight, this is the stuff you can probably do. So 6 through 11, and then day 2, 14 to 17. There's really not a whole lot. And then you got your spiraling, which you can always start. It's actually a majority of the work. Let's do. Yeah, lots of writing. I had to cherry pick because there's a few things we haven't done there, but. Yeah, I took 64 out because I didn't teach you the rational roots theorem. You can find the roots of that, but you're good. Okay. Due on Friday?
Yeah, Friday.
Due Friday. Okay. Like I said, tomorrow we'll get into a little more detail about how to use those theorems. Bueno, the rest of the time's yours to work. Please let me know if you have any questions.